Okay, each week I'm going to try to record a video of what you're going to be learning about and try to apply it maybe to a little more examples than what you might be getting out of the book. Then I'll also try to answer some of the critical thinking questions within that video and maybe get into a little bit of the investigations. I'll try to keep them short, 10 to 15 minutes typically. So week one, first chapter you're talking about, since you combine two chapters here, you're moving right through the course. You're going to be monitoring the weather. So what the heck does that mean when we talk about weather? So let's see if we can figure that out here. This thing moves here in a second. So basically we're asking what some of the characteristics of the atmosphere and the weather are. Well, weather can be described by a bunch of quantitative variables. Things like temperature. If you walk outside, you want to know what temperature it is, right? Or humidity, how much moisture is in the air. Is it cloudy? Is precipitation going to fall on you? What's the wind speed and the wind direction? Just some of the things that are kind of important to know if you're wanting to know what the weather is at your house. And weather is kind of interesting. It is what is happening in the atmosphere at a specific place and a specific time. In other words, if you walked out the house, the weather you're experiencing is what you're experiencing right now. If you went back in time and looked back to what it had been 15 minutes ago or whatever, that's past weather. So what we're going to be describing is weather, and weather is what is happening right now. Meteorology is just a study of that. What causes the weather, how it translates, how it moves, how it changes. And climate is looking at weather over long term. And then climatology is a little more complicated because it brings the study of climate, but also things that actually influence on the Earth's scale, climate and weather. So how do we access weather? Many of us do it on our smartphones, online, you hear it on television, radio. One of the key things about weather is we have to understand a little bit about time zones. Everybody, I believe, in this course is in the Eastern time zone. But when we're looking at weather, I want to know what the weather is at one moment in time over the whole United States. So if I was to look at a weather map, and that was in Zulu time, which is the time that it is in Greenwich, England, would be 12Z, well, 12A, 12 p.m. The time here would be 7 a.m. So there's a 5-hour time difference. There's a 6-hour time difference in Central. It's 7 in Mountain and 8 in Pacific. Yet, in order to draw a weather map, all those times, 4 a.m. would be the same as 7 a.m. here in the Eastern time. The observation that they took at Los Angeles, California at 4 a.m. could be used as exactly the same weather as we're getting at 7 a.m. So that's how the time zone relates to this. There are two basic types of weather systems, low pressure and high pressure. Low pressure generally brings bad weather to the area. High pressure usually brings good weather. Usually. Nothing's ever absolute in weather. So highs rotate clockwise. What's that mean? Well, if you have to find the center of the highest pressure and think about the clock hands rotating, the winds around that high are going to flow like the clock would. So they're going to be the east side of the high, they're going to be out of the north. The west side of the high, they're going to be out of the south. The low is the opposite, counterclockwise. So if you're on the east side of the low, the winds are coming out of the south. You're on the west side. The low winds are coming out of the north. So here you can actually see a depiction of that. They tend to move away from the center of highs and towards center of lows. Air masses are just a large volume of air covering a lot of territory. We'll look at one here in a little bit because there's a couple out on the weather map you want to see. And basically they're uniform, which is something that's interesting. Fronts separate air masses. A cold front will separate a cold air mass from a warm air mass. A warm front will separate a warm air mass from a cold air mass. So you can see here on a warm front, notice how the stratus clouds, see high cirrus clouds and all, well, are out ahead of it. Lots of long duration of cloud cover, whereas along a cold front, typically it's more cumulus and very short duration of cloud cover. Interesting thing you just saw was the fronts are three-dimensional. If you were to go back to that slide, you would see the warm front sloped up. So if you're at a different altitude, you may get into the warm air at a different time than if you're at the surface. And the same would hold with a cold front. Now, yeah, real close to the ground within 3,000 or 4,000 feet, probably not going to be a lot of difference. But if you get to like 7,000 or 8,000 or more, there could be pretty significant differences in timing of when a front passes your location. Some fronts have no clouds or precipitation with them. I had a cold front go through here yesterday. That dropped our temperatures. We had been 70 degrees here in southeastern Virginia the day before, and yesterday we were only about 53. It went through in the morning without any precipitation at all, just a few mid-level clouds. However, right now there's a warm front coming northward out of the Gulf of Mexico and along the southern United States. Lots of clouds and precipitation. As a matter of fact, the clouds have moved back into my house already. Coastal areas get things like lake and sea breezes. One of the coastal areas around you is Lake Erie. That gets the same kind of thing, especially with lake effect snows. Central U.S. has more thunderstorms or tornadoes. Florida has the most thunderstorms. If you were describing the state of the atmosphere at your house, you might want to know what the temperature was at its maximum, which actually occurs in late afternoon, mid to late afternoon. Why is that? Think about if you keep heating something up all day long, it can get warmer and warmer. That's what happens with the atmosphere. The sun just keeps heating it. Even though the sun reaches its maximum intensity around noon, it's still heating into the afternoon. Now, cooling, think about the sun setting. There's no sun there. So it takes longer and longer to cool, but around sunrise or whatever is when it reaches its coolest temperature. Dew point is just a measure of moisture, as is relative humidity. And precipitation, we measure it in usually hundredths of an inch or 1 inch of snow. Air pressure, rising or falling. If the air pressure is falling, we usually have low pressure. Remember, you have low pressure at the lowest pressure, literally. So if it's moving towards you, the pressure has got to drop. If high pressure is moving towards you, the pressure is going to be rising. And the National Weather Service issues hazards for various weather and considers it a watch if it's possible in the future, not too distant future, and hazardous warning when it's expected to happen. Clouds. High clouds are just little tiny ice crystals. Lower clouds are more water droplets, and that makes a difference in how the clouds look to you. Fog is literally clouds that are on the ground, and they can form in cloud sheets. For example, a cloud could be a stratiform cloud, which will just be a very flat cloud, and it can form in different layers. And because the winds move in different layers at different altitudes, it can move at different directions as well. So with that, let's take a quick peek. Here's a surface weather map. Here's low pressure. And there's another low pressure down here that's going to become the one that impacts a lot of the east coast of the U.S. as it's moving east. One of the things I wanted to show you here is air masses on this front. So if we were to look at these air masses, and if it comes back here, we'll look at it. So I'm waiting for it. I guess we'll do it this way. One of the things you're going to have to do this week in your e-investigations is actually do an analysis of pressure. So if I wanted to told you that I wanted you to analyze a 1024 millibar pressure, the blue are all pressures. So here's a 1023 and here's a 1025. So somewhere between the two of them is a 1024 millibar. You can figure out how close, probably closer to 1024 over here. Here's another 1024 and 1022, so it's somewhere between these. Here's a 1023 and a 1025. So you can see I'm just drawing a line, just connecting the dots. Well, that's how we get where air pressures are and how you analyze them. Let's see if I can get this interactive map here quickly one more time, and I'll try to show you some air masses. So an air mass is basically the same temperature, relative humidity over a large area. They're always associated with high pressure. Here is high pressure in northwest Canada, and I know it's difficult to read, but these temperatures under this high are generally around minus 30 to minus 40 degrees Fahrenheit. It is cold. Dew points are very low below that. So this is a continental polar or continental Arctic air mass. Here's a maritime polar air mass off the west coast of the U.S. It has temperatures in the 40s, low 50s, very high dew points. It's very moist. If you were to go down in the southeastern United States, just off the southeast coast, typically there's high pressure sitting out here, which would be a maritime tropical. More moisture, higher temperatures. So this is just some of the things you're going to cover in the weeks ahead in your course. So just kind of an introduction here right now.